Hey there, this is Reuven Lerner. Thanks for coming to my talk about dates and times in Pandas for Conf42. I am not going to be using slides for this talk. Rather, I'm going to be typing directly into the Jupyter Notebook, and I hope that you'll then see not only the sorts of cool things we can do with times and dates in Pandas, with Python, of course, but you'll also see the process that I can use to play with Jupyter and use it in order to do what I want to do here. In case you don't know who I am, as I said, my name is Reuven Lerner. You can learn more about me at lerner.co.il. I'm a full-time Python trainer. I have a whole variety of online courses that I offer to people around the world, everything from intro Python to advanced Python courses. I also have a set of courses called Weekly Python Exercise, and I have a number of free courses as well, including one about Python interviews and Python for non-programmers. Take a look at my site. It'll lead you to all the good stuff there, as well as to my blog and to my mailing list, the Better Developers list, which about 20,000 people subscribe to at this point. You can get that at betterdevelopersweekly.com. Okay, well, what are we going to talk about here? Because we're not here to talk about all my stuff. We're going to talk about Python Pandas. So we're going to be talking about dates and times in Pandas. So first of all, let's define dates and times, how they work in programming. Then we're going to talk about how we can load date time information into a data frame. And then what we're going to do is look at date, let's say extracting date time information. And then we're going to talk about time intervals, aka deltas, and how we can get that in a data frame. And then we will talk about how we can use date time objects in a data frame index. And then finally, we will talk about time series aggregation and resampling. Cool, that's a lot of stuff, but we're going to go through it and hopefully be really cool and interesting. I find this stuff incredibly interesting, maybe because I'm a nerd and maybe because it's actually interesting. So let's first start off with dates and times in programming. So dates and times. The thing is, there are two different ways to measure time. And I'm not talking about whether we measure with month, day, year, hour, minute, second, or whether we measure with seconds, which is sort of the traditional Unix way of doing it. Number of seconds since the 1st of January, 1970. We basically have two different things. We can talk about a time stamp, aka a date time, aka a point in time, and we can talk about a time interval, aka a time delta. So what are these different things? Well, basically a date time or a timestamp, depending on what language you use, what system you're using, this points to, or this is a specific point in time. So we can say, e.g., when you were married, or when you were born, or when you got, your first paycheck, or something like that is a specific point in time. There were many, many points in time before it, many, many points in time after it, but it is a specific point in time, and it will never repeat. It is unique. And so we can use all sorts of data structures in Python to do this. The time module provides us with all sorts of stuff for working with that. Also the date time module, which is sort of a higher level way of working with dates and times, can also do that for us. So that's great, right? If I have a date time, in fact, if I can go here, I can say here, import date time. I can say date time, now, date time, now. And you see, I get back, this is a pure Python date time object. It's in the datetime module, the datetime class. Now is the method we call that, and we get back, it's now 2021, 516, 12, 22, 552, and this is the number of, I believe it's milliseconds, microseconds, I guess it would be. Well, okay, what if I say start equals date time now, and then we wait a few seconds. Okay, I've waited enough. End equals date time dot now. Now we see that start is here and end is there. Okay, this is not a huge surprise. I waited, what does it look like, about 7 seconds, and sure enough, the second one is 7 seconds later. What if, though, I want to find out how much time passed between these two date time objects, right? So that's also a measurement of time, but it's not a measurement of time in the same way. And I must say, it took a long time, no pun intended, it took a long time for me to understand that when we talk about time as people, we are actually using these two different ideas. One is a specific point in time, one is a length of time, a span of time, or as I called it before, a time interval, a time delta. For example, let's say you have a meeting that starts at 1 p.m. and it will go from 1 p.m. to 2 p.m. So the start time will be at 1 p.m. The end time will be at 2 p.m. But the length of time it takes will be 1 hour. That's a time interval. That's a time span. And what if you get a call just before the meeting starts and they say, oh, we can't meet now. Let's meet half an hour later. We'll just push it back. Well, everything gets pushed back. So the start time and becomes later, the end time becomes later, but that time interval will actually be the same. It's still going to be 1 hour in length, as if we're lucky enough to have 1 hour meetings, right? So how can I deal with that in Python? Well, I can actually just say end minus start. And look what it does. If I take one datetime object, I subtract it from another datetime object, I get a time delta object, datetime.time delta. And it's kind of weird in that it's going to measure here seconds and microseconds. If it's really large, it'll measure in days, seconds, and microseconds. But those are the only components of a time delta that we really need to think about and worry about. Even though it's covering any sort of time delta, these are the three sort of pieces that it uses to measure that. So anything up to a second will be in microseconds. Anything between a second and a day will be in seconds. Anything a day or greater will be in days. And you can, of course, mix these together as we see here on my screen. Okay, so we have datetime objects and we have time delta objects. What in the world does this have to do with pandas? Well, it turns out that when we're working with pandas, we actually deal with a lot of date and time data. So I'm going to load up now one of my favorite data sets to play with. So I'm just going to first say PyLab inline. Let's say import pandas as PD and from pandas import series and data frame. Okay, so I've loaded up. PyLab inline is for using Jupyter. It makes sure that NumPy and Matplotlib are both loaded and they're in the current namespace. I load up pandas because it's not loaded by default. And then from the pandas library, from the pandas module, I'm going to load series and data frame into the current namespace just because it's super useful to be able to do that. And now I can actually create a new data frame, and I can do it based on a file. And a whole lot of files in the world of data science are in CSV format. So it's not a surprise. We have PD, read CSV, and I can just read in a file here. Well, what is this file that I'm going to read it? Let's just take a look at it first, this CSV file. So this is taxi.csv. This is from a number of years ago. It's a little out of date, but not like we'd still do analysis on it. It's kind of fun. These are taxi rides from New York City from 2015. And basically, when I was growing up, and even though I live in Israel now, I grew up in the New York area. If I wanted to take a taxi, so I get into the taxi, tell the driver where I wanted to go. And when we arrived there, the driver would tell me, well, it was written on the meter, how much I had to pay. And then basically I would pay the driver however much it was, add a tip, and we would be done. I'd get out, get a receipt as well. Well, nowadays, of course, in New York, it's way more high tech than it was back when I was a teenager. Nowadays, when you get into a taxi, there's actually a computer in the back seat. And the computer you think is there just to annoy you with television ads and movies and all sorts of spammy stuff. But at the end of the trip, it allows you to use a credit card to pay. And then it asks you how much you want to tip. And it's, I think it's like 20, 25, and 30%, something like that. People definitely pay more for tips now than they did when I was a teenager, when we were told it was 15%. And of course, you can choose something else if you want. So basically, this is a record of every single taxi ride in New York, where you can go to the New York City open data system and download taxi rides from just about any time you want. I think the last 10 or 15 years. I don't remember exactly when they started recording this. So the computer is not just there to annoy you with ads and not just there to help you with taking your credit card, but it also records a lot of information about the trip so that you can use it in all sorts of analysis, or so that the Taxi and Limousine Commission in New York can use it for all sorts of analysis as well. So this is from a number of years ago. And you'll see they have a whole bunch of different columns here. The vendor ID, that is to say, which company made this computer. The pickup date time and drop-off date time, we're going to be getting back to this in just a little bit. Number of passengers. How far did you go in miles? The pickup longitude and pickup latitude. And these actually have been removed from more recent data because I think people realized it was kind of creepy to have this open data say where you're going from, where you're going to, what rate were you doing, storm forward flag I've never quite understood, truth be told, where you dropped off longitude and latitude, how you paid, how much the fare was, how much extra, tax, tips, tolls, improvement surcharge, and then finally the total. So we can read this data in, and if we read it in, then we can do some analysis of it. And I love to do analysis of this in all my data science courses that I do for corporations and for individuals. Well, let's read it in. If I say here df equals read CSV of taxi.csv, it actually gets read in very, very nicely, right? We can see that we have the headers here and we have the rows, and this is only the head. So that's only going to show me the first 5 rows in this file. But if we ask, df count, we're going to find out that there are actually 10,000 rows in this file, and there are no NaN values. So every single column is going to give us 9999, 10,000 minus 1. And so what else do we have? Passenger count, and this and this and this, also really great stuff. The thing is, if I now say df.info, show me pandas, what kind of data do we have for the pickup and the drop-off date times? We have objects. And df.info tells us not about the data in the data frame, but about the data frame itself. How is it defined? What does it have? And we see that we have two objects here. Now you might say, oh, that's fine, right? Objects are good. But it's not actually that good, because what it means is Pandas wasn't able to figure out what kind of data it was. It's usually able to figure out integers. And it's usually able to figure out floats, and we see that here. But anything else, it just says, oh, that must be an object, and calls it an object, but it's really a string. So what we really have here is string data. Now I'm going to reduce the number of columns we have, because we don't really care that much about a whole bunch of them for our purposes today. So I'm going to say df equals pd read CSV, and I'm going to say here, oh yeah, taxi.csv. I'm going to say here use calls equals, and I'm going to say tpep pick up datetime. I'm going to say here tpep drop off datetime. I'm going to say here passenger count, and then I'm going to say here let's do trip distance, and then I'm going to say here total amount. These are like the columns that I enjoy playing with. And so now if I do a df info, it's at least fewer columns, but we still have the problem we did before, that these are all objects, these are all strings. Like, what are we going to do now? I need to somehow tell Pandas, listen, Pandas, because if we look at it now, it looks like a date and time, right? I mean, it has dates, it has times, but these are being read as strings. If we want to do any sort of date time manipulation, we're really going to need to have it read in as date time objects. So how can we do that? Well, it's not going to guess on its own. So we're going to need to give it a little bit of a kick. We're going to need to give it a little bit of a hint. And what we can do is we can say here, parse dates equals, and I'll say here which columns I want, tpep pick up date time, and tpep drop off date time. And we do that, and now I look at df, and it looks exactly the same. The visual part of this, or the printed representation, is exactly the same. But if I say df.info, oh, look at that. Now we see that we have 64-bit date time objects. And it's even telling us it's down to the nanosecond, which is kind of nice. Because, you know, I hate to be late to a meeting by a nanosecond, so it's good that Pandas can keep track of this stuff for me. So this is now how we're going to read it in. Now you might be saying, wait. It's very nice that when I read the data, I'm just going to scroll up here for a moment so you can see. It's very nice that Pandas was able to read this sort of date format and understand that this is a date. So I tell parse dates, and it says, oh, I see, year, month, day, hour, minute, second. This is indeed a common date format. It's also one that's very easy to parse. But what if, just what if I have it in a different format? What if I have it in month, day, year format, right, which is pretty common in the United States? Yeah, then it might have a harder time understanding it. It can understand it, but might have a harder time. Moreover, is it month, day, year, or day, month, year? Is it American style, or rest of the world style? I should say, like, European style, shall we say? Because typically in Asian countries, they actually use this style of, from biggest to small. So year, month, day, hour, minute, second. So if we say basically, like, how does it know whether the month comes first or the day comes first? If I have 1/2/2021, is it the 1st of February or the 2nd of January? So it turns out that when I read in a date and time, or when I read anything, if I do alpha pd read CSV, there are a ton of different options that we can provide. One of them, of course, was parse dates, and I told it which ones to do. But there are a whole bunch of other things that have to do with dates. And one of them here is, here we go, parse dates. Okay, that's good, equals false. Infer datetime format, like, should it assume that it knows the format? If it doesn't infer it, then what are we going to do? Well, we can play with this a little bit. Keep date call, date parser, and this is where you can, if you really want to, provide a custom function that will read in the date and then spit out a datetime object based on its parsing. And this is what I was talking about here, day first equals false, meaning, is the first number there the date, or is the month? So day first equals false means no, it's the month. So if you're reading in European dates, you're going to have to say day first equals true. Okay, fine. Then we got all sorts of other stuff there, but we're going to ignore those for now. So I've successfully read this data in, and now I can say df.info, and we see that it's dates, and I say df.head 10, and we see that it's dates and times. Fantastic. Well, now, how does that help me? Like, what have I gotten from this, that these are actually date and time objects? Well, I can now perform all sorts of calculations on them. For example, maybe I want to find out what was the hour at which each of these trips took place. How can I find that out? Well, I can say df of tpep, let's type this quickly, df of tpep, date time, and I run that, and we get here that column. That's not a big surprise. Wouldn't it be nice if I could sort of go through each of these and say, I just want to pull out the hour, I just want to pull out the minute, I just want to pull out the month? All reasonable, right? Things that we would want to do with dates and times. So it turns out that there's a DT accessor object. This is similar to the stir accessor object that you might be familiar with, and this allows me to pull out date and time information. So if I say DT, now we're going to the datetime accessor. Now it has its own attributes that I can use to retrieve stuff. So I say DT hour, and look at that, we're pulling out the hour. I can say DT day of week, and it'll tell me what day of the week it is. I can say DT month, and it'll do that. I can say year, that'll allow me to do it. Yeah, it's leap year. is quarter end. So I can basically pull in all sorts of really useful, interesting information based on this DT accessor. All right, and so the DT accessor has a whole bunch of attributes that allows us to do these. And you might be saying, okay, I can understand hour, I can understand minute, but what's with this is quarter end? Why in the world would I care if it's the quarter end or not? And the answer is that, well, you have to remember that Pandas was developed in an investment firm. And so they were trying to do all sorts of, or actually Wes McKinney, who invented Pandas, was trying to figure out how can I use Python to perform these sorts of calculations that are typically traditionally done, say, in Excel. And if you are working in investments, then you want to know, is it the month end? Is it the month beginning? Is it a holiday? Is it a quarter end? And so there are all sorts of attributes you can use to pull information out like that from the DT accessor. And then you'll either get a number out, as we did for, say, minute, or you'll get a true false value. You have to decide like what you're going to do with that. So how can I use this? Well, maybe I want to know, what is the distribution? Like, I have all this data here. I have 10,000 taxi rides. Is this a reasonable distribution of hours across the day? Is this a reasonable distribution of days across the week? So let's find out. I'm going to say here DT hour. Let's find out here. DT hour. Let's do a value counts. Because remember, what I'm getting back here is a series. So because I'm getting a series back, I can apply the value counts method and thus get back what's basically a count of how often each of these values appears. And you can see very clearly here that this is not a representative sample, that we have a whole lot of trips from 11 a.m., some from 3 p.m., some from midnight, and a handful from 4 p.m. So if you're trying to make any sorts of assertions based on this data, they're probably going to be fundamentally flawed because they don't actually have anything to do with, it's not a real distribution of data. So you might be making all sorts of mistakes. What about days of the week? Can we do that? Well, I'm sure I can check here, day of week. And we get value counts. And we see that once again, the distribution is totally wacky. You can't really make any sorts of serious decisions based on the data here. Or if you do make decisions, you better go check them based on actual more representative data. So we can find out this sort of information, then plot it accordingly, or just make assertions accordingly, or we can pull things out based on that. So I can say, for example, df tpep pickup daytime dt day of week equals 1. That's going to give me, of course, true or false. I can use that as a Boolean index into df, and then I get back only those rows in which the day of week was 1, meaning Monday. And then I can even use this, right? This is like a good start, but I can even say, let's apply that actually just to total amount. And then I can get that. So I can find out what's the total amount for this day of week. I get, how much do people pay on average on Monday versus, say, Sunday? I can pull this out here and say day of week 0, and get that out as well. Right? We see that basically on Sundays they paid more. Can we really say that? I don't really think so given this data, but given real data, you absolutely could. So that's like an initial view of what we can do with date and time data. And for many people, that's great. That's enough because basically we can use that. And then we can do all sorts of analysis. I can find out on what day of the week, on what day of the month, or what hour of the day did people buy the most from our online store? Or do they buy the least? Or so then we can sort of juice it with, let's give them some coupons during the dead time, sort of like a happy hour at a bar, except that, it's online. So less physical drinking, maybe, at least we're not spreading across the, the network there. But maybe I want to find out not at what hour did things take place or what day did things take place. Maybe I want to find out how long different trips were. Well, we saw already before that if I have a date time and another date time, I can subtract them one from the other and I will get a time delta. Guess what? We can do that here. So I can say df of tpep drop off date time minus df tpep pick up date time. And if I subtract those, oops, I didn't mean to do that. I did an E. I meant to do minus. Let's go reload our file again. Read CSV. Now I'm going to go down to the bottom. I'm going to say minus, not equals. There we go. And what do we see? We actually see a time delta object for each of our elements. And you see here, the D type is indeed time delta. Well, what I'm going to do now is I'm going to create a new column. Say df of trip time equals. Well, right, equal sign seems to be like really trigger happy today. And now if I say df head, look what we're going to get. And what we have then is the pickup, drop off, passenger count, trip distance, total amount, and then we have the trip time, which is pretty great. So now I can find out what was the trip time. Well, how am I going to search for that? I could say like, df of trip time equals, then we can say like what, 0 day 00 28 23. Could I do that? I can, right? And it'll find all the ones that were like that, which is going to be 1. So that's like one way to do it. But here's the thing, I can also do comparisons. I can say df of trip time is less, or let's say, less than, and I can say 00, let's do 01, 00, 00, meaning how many trips were less than 1 hour in length. And this gives us a Boolean index or Boolean series, which we could apply as an index. So this will give us all the rides that took less than 1 hour, which we'd hope is quite a lot. How many rides took less than 1 minute? Well, we can search for that too, and we'll find, you'd be surprised, 84 of the rides out of our 10,000 actually took less than 1 minute. Now, if you're thinking, this is kind of weird, how am I comparing this date time object, or this time delta object, I should say, with a string? Well, that's because they're automatically doing some conversions for us. That's because Pandas is smart enough to say, wait, if I have a time delta here and I have a string here, maybe, just maybe, I should do the comparison. It turns the string into a time delta, and then it can do the comparison, which is pretty snazzy. I can even use some words. I can say like, hey, not 001, I can say 1 minute, or I can say 1 second. And of course, I can make, by the way, like, look at that. There are a whole bunch of them that took less than 1 second. And you thought traffic in New York was always terrible, right? I can also say, like, how many of them were more than, 10 hours? Were there any taxi rides that were more than 10 hours? Yes, there were. There was one ride that actually took 12.5 hours. So much for no traffic, right? But it's okay. They only had to pay $11 for the privilege. And they only went 1 mile. So I guess actually the traffic was pretty bad. Or this is representing some data that's a little, shall we say, not reliable. So we can use timestamp objects. We can read them in. We can use them, extract from them. But we can also use time delta objects and see how they compare them on our own and look for them in different ways. So these are two major ways that we can use dates and times in Pandas. But it gets better than that. As you might know, Pandas indexes are really powerful. And right now what we have is just a bunch of numbers, right? There's nothing wrong with that per se. But if I say head, let's say 20, we're going to see that the indexes are 0 through 20. And that's because we didn't set them to be anything special. And the default index is just integers from 0 to whatever. But one of the nice things about Pandas indexes is that we can set them to be anything we want, more or less. They can be just about any data type, and then we can retrieve based on those. And what we can do then is we can say, hey, I actually want one of these columns to be the index. And we call that a time series. So what I can do is I can say df set index be df tpad, let's say pick up date time. And if I do that, look what I get back. I get back a data frame that's identical to what we had before, except that now the index is that column. And you can even see sort of this historical remnant here of we know that the column was originally called that, even though indexes aren't really called by name. There's just one problem with what I did here, which is that I did not actually change the data frame. This returned a new data frame. And so if I want to change it, it's really tempting to use in place equals true, but don't do that. The Pandas core developers have told us now for a few years that's not the right way to do it. Instead, what you should do is say df equals that. And what I'm doing is I'm taking the new data frame that I got back and assigning it to df. And now if I say df head, sure enough, we've changed it. Okay, that's nice. But like, so what? Well, actually, remember that we can retrieve things based on an index. That's sort of the whole point. So I can say df lock of 2015, 06, 02, 11, 19, 29. And remember also that indexes in Pandas are not guaranteed to be unique. Now, this might sound weird, but it means that I can pull out all of the trips that took place on the 2nd of June, 2015 at 11, 19, and 29 seconds. And we see that there were 3 trips that started at exactly that time. But it gets better than that, because if I now use not the entire timestamp, but part of it, if I chop off the seconds from there, now I get everything that matches any seconds for those minutes. It's like having a star there, except, obviously we don't use a star. And so now we see it's 146 trips that took place on that day, at that time, at that minute, but any seconds. So sometimes it's 56, sometimes 59, sometimes it's 30, it could be any of those. And we can keep doing this. I want to find out everything that happened at 11 a.m. any minute. I want to find out anything that happened on that date any time. And so this allows me to really sort of find stuff based on those dates and times with a lot of flexibility, which is fantastic. The other thing I can do is I can use a slice. So I can say df.lock of 2015, let's say 06, 02, 11, 19, 29, all in, and then we'll say 2015, 06, 02, 11, let's say 29, 29. So actually, let's even say like 2029. So just 1 minute. And this will now give us all the writes that took place in that 1 minute interval from 11/19/29 until 11/20/29. Notice it'll also be up to and including, because when you do a slice in Pandas and you don't have integers, or you don't have numbers, I should say, actually, I guess it's just integers, then it's always up to and including, as opposed to with integers, it's up to and not including. So this is actually a really powerful technique as well. So if you're looking to find out, hey, show me, right, during this interval, what was the average trip distance? Well, I can do that. I can just say here, df lock of that, trip distance, and I can say mean, and we'll find out what was the mean trip distance during this little slice of time. But what might be fun to do, or even useful, not just fun, is to say, I want to find out from the first timestamp we have to the last one, we know that it's not going to be continuous because we know it's going to be chopped up and we have some data, we don't have some data. So from the earliest one until the latest one, in let's say 1 hour intervals, for each of those hours, what was the average distance? What was the average total fare, total amount? Can I do that? Yes, I can. Because now that I've set my index to be a timestamp, now that we have its time series, now I can say df.resample. And resample allows me to say, I want to go based on 1 hour. So again, it's going to take the earliest time, the latest time, and find all the times in between in 1 hour blocks. There might be no data for a bunch of those, and that's okay. In which case, we'll just get none. So if I resample, look what we get back. We get the datetime index resample. Very exciting. And where do I know that it's 1H from? Because I looked at the documentation, and quite frankly, except for a few of them, I have to look it up for all of them. So, okay, 1H, now what? Now I can say, show me, let's say, trip distance mean. And look at that. I now have the mean trip distance for every hour from the earliest time to the latest time. Now, it's not showing me everything because like Pandas traditionally doesn't show me everything, and there are a lot of NaN values. So once I get back to the series, I can actually say drop NA, and you're going to see it's going to go back to be those 4 hours that I had before. Okay, not so exciting, but fine. But what if I were to say, like, for example, one, I think lowercase m is minute. No, it's month. But you can use here any number you want. You can use here any of the extractors that you want. I know about hour, I know about day, but I don't really, again, the others I have to just sort of look up because there's just so many. And so you can play, I can say here, well, what about like 8-hour intervals or 12-hour intervals? Or I can say in each even, 12-hour interval, how much did people go? How far did people go? Or how much did they pay? By the way, if I take off that trip distance, let's say I do it applied to the entire data frame, and there we go. I'm going to get for each of the columns and then for each of these timestamps. And so you can do this with resampling on any interval you want. You can pull out columns if you want, but you don't have to. And then you can use any aggregation function that you want as well. And the aggregation functions are min, max, mean, standard deviation, count, and I'm sure there's some others, but those are the main ones that we would use. And so, again, they have to aggregate. They have to give us a full answer over a whole bunch of things, but it allows it to split it up by time. And the fact that it doesn't care where we have data, it's just going to sort of go from that earliest to latest, makes it especially useful. Okay, I hope that you enjoyed this talk. I hope it was useful, mind-opening, and so forth. Once again, I would be delighted to hear from you if you have comments or questions about this talk. I can also send you a copy of the Jupyter Notebook that I used for this, so you can just drop me a line. You can always catch me on Twitter as Reuven M Lerner, or you can catch me via email at reuven@learning.coil. And once again, my newsletter, Better Developers, goes out every week to about 20,000 developers, and I would love to have you join and learn with me with a new article about Python free every Monday. Thanks so much for watching my talk. I hope you enjoyed. I hope to hear from you. Enjoy the rest of the conference.